Pulling the primer plunger increases chamber volume, which decreases the pressure in the chamber below that of atmospheric. Fuel in the tank is forced along the fuel lines, through the inlet check valve and into the pumping chamber. Pushing the plunger into the barrel decreases the volume in the chamber, which forces fuel out through the outlet check valve. When the priming pump is not in use, the hand knob must be screwed closed. This stops fuel leaking out past the plunger and also stops air leaking into the priming plunger barrel. This section examines the inline injection pump. Some diesel engines use inline injection pumps to meter and raise the pressure of the fuel. The basic principle is for a plunger to act on a column of fuel to lift an injector needle off its seat. Inside the pump is a pumping element and a delivery valve for each cylinder of the engine. The element has a barrel and a plunger that fits inside it. Their accurate fit and highly polished finish ensures only minimal fuel leakage past them without needing positive seals. The barrel usually has two holes or ports, called the inlet port and the spill port. They connect the inside of the barrel with the gallery. The gallery contains filtered fuel from the low pressure system. At the top of the barrel is a delivery valve holder, and the pipe to carry fuel to each cylinder. The upper end of the plunger has a vertical groove extending from its top to an annular groove. The top edge of this annular groove is cut in a helix, also called the control edge. Some pumps have a helix cut on top of the plunger. A camshaft, cam follower and spring move the plunger in a reciprocating motion. When the plunger is below the ports, fuel from the gallery enters the barrel above the plunger. This ensures the barrel is full of fuel. As the camshaft rotates, the plunger is pushed past the ports. The highly polished surfaces cause a sealing effect, trapping the fuel above the plunger. Moving the plunger further raises the pressure of the fuel. This forces the fuel out past the delivery valve along the fuel line to the injector. Fuel flows to the injector until the control edge uncovers the spill port. The pressurized fuel above the plunger then moves down the vertical groove to the annular groove and into the spill port. The delivery valve stops fuel leaking from the pipe back into the element. It reduces pressure in the fuel line to ensure there is no dribbling by the injector. The delivery valve has a relief plunger and a conical face which is held against its matching seat by the delivery valve spring. The relief plunger on the valve is a close fit inside the bore of the delivery valve seat. When the fuel pressure rises, the delivery valve is lifted off its seat. When the plunger is clear of its bore, fuel flows to the injector. When injection ceases, the pressure below the delivery valve drops to gallery pressure. Fuel pressure above the delivery valve forces the valve towards its seat. The relief valve enters the seat bore, sealing the volumes above and below the delivery valve. Further movement of the delivery valve towards its seat increases the volume in the injector pipe and reduces the pressure in there. This drop in pressure causes the injector needle to snap shut, helping to prevent fuel dribble from the injector. The conical face of the delivery valve then contacts the seat, further sealing the plunger from the injector pipe. Rotating the plunger controls the length of the stroke for which the spill port is covered. This is called the effective stroke. It influences how much fuel is delivered to the injector. A short effective stroke means a small amount of fuel is injected. A longer effective stroke lets more fuel be delivered. To stop the engine, the vertical groove on the plunger is aligned with the spill port, which stops pressure in the barrel rising. The plunger is rotated by a control sleeve, a rack and a pinion. Moving the rack rotates the pinion, the control sleeve and then the plunger. The rack's movement is controlled by the governor. This section examines the distributor type injection pump. The distributor type pump uses a vane type transfer pump to fill the single pumping element. This then raises fuel pressure to injection pressure. A distribution system then distributes fuel to each cylinder in the firing order of the engine. The most common type in light automotive use is the Bosch VE pump. A drive shaft driven from the engine rotates a plunger and a cam disc. Cams on the face of the disc have as many lobes as cylinders in the engine. A plunger spring holds the cam disc against rollers that rotate on their shafts. The lobes move the plunger to and fro in its barrel, making it rotate and reciprocate at the same time. Its rotation operates the fuel inlet port to the pumping chamber, and at the same time distributes pressurized fuel to the correct injector. The reciprocating motion pressurizes the fuel in the pumping chamber. The plunger's pumping action forces fuel through a delivery valve to the injector. This pump is for a 3-cylinder engine, so it has 3 delivery valves. The barrel has 1 intake port and 3 distribution ports. The plunger has a central passage, a connecting passage to the distributing slit, and a cross drilling to a control sleeve. As the plunger rotates, each intake slit aligns with the intake port, and the distributing slit with the distributing port. As the plunger rotates, the intake slit moves away from the intake port. At the same time, the plunger is acted on by the cams, causing it to move axially along the barrel, pressurizing the fuel in the pumping chamber. The distributing slit now uncovers the distribution port, and the pressurized fuel passes through the delivery valve to the injector. Further rotation of the plunger closes off the distribution port and opens the intake port. At the same time, the plunger spring moves the plunger back along the barrel for the next pumping stroke. For intake, fuel from the feed pump reaches the open intake port in the barrel. The intake slit aligns with the intake port, and fuel fills the pumping chamber and passages in the plunger. For injection, the plunger rotates to close off the intake port and moves along the barrel to pressurize fuel in the pumping chamber. The distributing slit aligns with the distribution port, and the pressurized fuel forces the delivery valve off its seat and reaches the injector. In this phase, a cut-off port in the plunger is covered by the control sleeve. To end fuel delivery, the plunger's cut-off port moves out of the control sleeve and lets pressurized fuel spill back into the pump housing. This relieves pressure in the pumping chamber, the delivery valve closes, and injection ceases. Metering the fuel is controlled by effective stroke of the control sleeve, and that's determined by the action of the governor sliding the control sleeve along the plunger. Sliding it one way opens the cut-off port earlier and reduces effective stroke. Sliding it this way delays its opening and increases effective stroke. The governor changes the position of the control sleeve to vary the quantity of fuel delivered according to throttle position and load. When the ignition is switched off, an electrical solenoid closes off the intake port and stops fuel delivery. This section examines diesel fuel injectors. Most diesel fuel injectors use the same basic design made from heat-treated alloy steel. The actual shape will vary according to the application. The injector assembly has several main parts. The nozzle assembly is made up of a needle and body. A pressure spring and spindle hold the needle on the seat in the nozzle body. A nozzle holder, sometimes called the injector body, may allow for mounting the injector on the engine and some method of adjusting the spring force applied to the needle valve. A cover keeps out dirt and water. The injection pump delivers fuel to the injector. The fuel passes through a drilling in the nozzle body to a chamber above where the needle valve seats in the nozzle assembly. As fuel pressure in the injector gallery rises, it acts on the tapered shoulder of the needle valve, increasing the pressure until it overcomes the force from the spring and lifts the needle valve from its seat. The highly pressurized fuel enters the engine at a high velocity in an atomized spray. As soon as delivery from the pump stops, pressure under the needle tapered shoulder drops, and the spring force pushes the needle down on the seat, cutting off the fuel supply to the engine. Some of the fuel is allowed to leak between the nozzle needle and the body to cool and lubricate the injector. This fuel is collected by the leak-off line and returned to the fuel tank for later use. There are two main types of injector nozzle, hole and pintle. Hole-type nozzles are commonly used in direct injection engines. They can be single-hole or multi-hole, and they operate at very high pressures, up to 200 atmospheres. They give a hard spray which is necessary to penetrate the highly compressed air. The fuel has a high velocity and good atomization, which is desirable in open combustion chamber engines. In pintle-type nozzles, a pin or pintle protrudes through a spray hole. The shape of the pintle determines the shape of the spray and the atomization of the spray pattern. Pintle nozzles open at lower pressures than hole-type nozzles. They are used in indirect injection engines, where the fuel has a comparatively short distance to travel and the air is not as compressed as in the main chamber.